So you can fire on.
Right, so good evening, everyone. Can you guys hear me?
Yeah, we can. Good evening, Dr. Van. So,
All right.
oh yeah, I'm an meeting host, right? So let me introduce. Um, so we have on the call our senior colleague Joseph, Joel. We are very glad to have him in our midst, guide us always. And then for today we will be discussing about research fundamentals and the key things that we're going to be discussing. So yeah, we have the privilege to have Dr. Ben. Yeah, I call him Dr. Ben. We call ourselves Doctor. That's very crazy. Take us research fundamentals, and on that we would discuss key things like scientific methods, research ethics, questions formulation, and hypothesis. We plan to make this a single session, but due to how cumbersome some of these topics are really to our understanding, we may eventually have to make it a two-series class. But if we're able to accomplish the stated goal, this will be a one shot. So I introduce Dr. Simon Anongo to take us on research fundamentals. Dr. Ben, you have the floor.
Yes, thank you so much, Dr. Hendricks. I appreciate, and then thank you, Sir Joel, for this privilege you have given to me to present today on research fundamentals. All right, so as Hendricks said, I'm going to be presenting on research fundamentals. Yeah, so on my slides here, you know, I have an opening thought, and you guys may, think of it. Everything that we have today, everything that we, may think of that is good today, being it medicine, being it, your cell phone, you know, anything at all, um, exists because someone somewhere asked the question, and then the person refused um, to guess the answer. The person refused to quit. All right. So you may ask why research matters. Research matters because it drives innovation and development in our lives. Research helps to solve real world problems, and then research forms the foundation of science and technology. Right. Someone before once asked that all this research, all of this school that people are going, people are talking about PhD and all of that. What is the importance of all of these things? So I just said, let me give an example here. And do you know that the Google that we used today was a PhD project? It was a PhD thesis by two PhD students at Stanford University in California, United States. Right. So I want you to know that research is not just academic. Research is the foundation of the world's most powerful innovation. So you can imagine that a PhD thesis or a PhD idea have now become a $2 trillion company today. All right. So that's how um, powerful research is. Right. So what we are dealing with today is a research fundamental. So what are research fundamentals? Research fundamentals are the core principles and building blocks that guide how research is properly done systematically. If you're interested in research, research is not something that you can do the way you want. It is something that must follow a step-by-step process. I mean, a structured process, right? So there are core principles that guide how this thing called research is done. I said here they include what research is, why do we do it, types of research, how to identify a problem, how to review literature, research design and methodology, data collection and analysis basics, and then ethics in research. These are all the things that constitute research fundamentals. So I am going to be taking them, one after the other, so that we understand, right, what um, research fundamentals are. Right. So by the end of this session, I believe everyone here on this course should be able to know and understand what these core principles, core principles are. So you may ask, what is research? It is one of the core principles of these research fundamentals. What research is, I said, it is a careful, systematic, like I said before. It is a structured process. It is something that you don't just do it in how it must fully a step-by-step process. You know, investigation or inquiry into some field of knowledge that is undertaken to establish facts or principles. Um, I can say, in other words, that research is just giving answers to to questions or hypotheses. By hypothesis I mean uh, you know the, something that is intended, or a proposal that is intended to explain certain facts, right? Can you guys hear me, please?
Yeah, very clear. I can hear you.
Oh, okay, that's great. So I said research is just you answering or giving answers to questions or hypotheses. And I said hypothesis there is just like a proposal that is intended to answer certain facts and observation. So there are three core elements of any research, no matter the field of study. Every research here these three things. Number one of it is a question, something unknown that needs answer, that need answers. Something that is not known that needs to be answers. Number two is a process, a structured method for finding the answer, right? And number three is evidence. There must be evidence. If there's a problem you've identified that you want to solve, right? There must be evidence of what you have done, evidence of data, observations, or findings that support a conclusion. Right? So without all of these three, then it is not research. It is just an opinion. Right? So these are the core elements of any um, research at all. So we have what types of research? A research can be classified in three major ways. By approach, by purpose, by method. So research by purpose, you know, purpose there answers the questions why. Why are you doing the research? Under this, we have basic, fundamental, slash pure research. This type of research is purely done to expand knowledge, right? It is there is no immediate a practical application in mind. It is done by curiosity and the desire to understand, which is usually conducted in universities and a research institution. An example, let's say you're studying how electrons behave in a new material, not to build anything yet, just to understand. Secondly, we have applied research. This type of research is done to solve specific real world problems. It is built directly on finding from basic research, right? Let's say you're using the knowledge of electron behavior to develop a battery for EVs, electric vehicles. It is applied. It is done to solve a real world challenge, a problem. And the third one is action research under research by purpose. Remember, right? This type of research is done to solve an immediate problem. An immediate problem. Let's say, for example, a teacher is researching why students in their own classroom are struggling with a concept, right? Then they're testing the solutions. The second one is research by approach. Under this, we have qualitative research, we have quantitative research, and we have mixed methods. So by quantitative research, I mean this type of research deals with numerical values, it deals with measurement statistics, and it answers questions like how much, how many, how often, and is there a relationship. Then qualitative research, which is the second one under research by approach, deals with words, meanings, experiences, and observations. Here the researcher explores depth and context, right? It answers questions like why, how, and then what does it mean? That is for qualitative. Recall I said quantitative deals with numerical values, numbers. Why qualitative? It's words, experiences or observations and what have you. The third one, like I said, is mixed methods. Mixed method combines both quantitative and qualitative approaches that uses both numbers and stories to get the full picture of your research. And this combined approach is more powerful than either of the approach alone. It is more powerful than just qualitative. It is more powerful than just um, um, quantitative, right? So I gave an example here. I said, let's say, for instance, you're measuring catalyst efficiency. You know, catalyst efficiency is the quantitative, and then you are interviewing the research team about the challenges they faced during the experiment. That is qualitative, right? So we have on my next slide, I have, how do you identify a research problem? Remember, a research problem is one of the core, principle of research fundamentals. When we start research, or when any researcher starts research, a problem drives them, right? A problem is what drives a researcher. So first of all, you may ask, what is, a research problem? A research problem is simply, a situation. It is a gap or a difficulty that needs, to be understood, that needs to be explained, that needs to, be investigated. So if there is no problem, then there is no research. So the problem, like I said, is the starting point of everything. Is the starting point of what drives you to doing that particular research. And so how do research problem come? How do you identify um or how do you get these research um, problems, right? Number one, I said personal observations. Let's say something you notice in your everyday environment that seems wrong, you know, something that needs an explanation, something that is not efficient, right? You observe it, and then you notice a problem, and then that becomes something that you want to look into. That becomes something that you want to investigate, and that will be the beginning or origin of your um, um, research. Number two is reading literature. You read existing literature, and you notice something that the author said needs further study or findings that that conflict with each other. When if you pick any research paper, right, and you go to the result and conclusion of that paper, you are going to see that the researcher will explain you know the interpretations of the results. The person will explain the implications of the results, and then under that same discussion, the person will explain the suggestion. The person will talk about, or the person will give suggestions for further research. That is what is called research gap. In any research paper at all, that is a research gap, and that can be the foundation for your own research problem, right? Where you begin from there, you pick, okay, this researcher has done this work, but then the person is saying that there is something that I could not do while I was doing this research. This thing needs further investigation. So anybody who will be looking at this thing in the future, this is what the person should do, right? So that is a problem. That is a gap. You can pick it up from there. You continue with it, right? The third one is professional experience, something you encounter in your field of work or study that lacks clear answer, right? It's also a problem. Number four is social or community issue, real problems affecting people that needs research based solutions. Please, can you hear me once more? Let me know.
Yes, we are getting you.
Yeah, we are
Yeah,
hearing you, sir.
yeah, yeah. So number four, I said research, or social or community issue, real problems affecting people that needs research based solution. I attended a webinar once some time ago, and I listened to a PhD student. This guy is currently doing his PhD in the US, Assad, when he was an undergraduate student here in Nigeria, he studied zoology, but then he's doing his PhD today in neuroscience. So he said something. He said in one of the his classes, there was this professor. This man kept on talking about this disease called, is it Alzheimer's disease? I think this thing has to do with it affects old people, and it's something that has to do with the brain, and something like that. Right, so he said this man kept on saying that there's no cure for this particular disease. So this thing was a problem to this guy. This guy kept on asking, why is it that this disease has no cure, right? And he kept on researching, right? After his undergraduate degree, he was looking for ways that this problem can be solved. Then he started applying for schools because he knew that what he wanted to do, the solution he was looking for, I think Nigeria don't really have that capacity to help him solve that problem. He started looking for ways, started applying for schools, and then he got admission into the US, West Virginia University in the US, from zoology to neuroscience. And currently he's working on estrogen, is phytoestrogen. I think some kind of medicinal plant that can help solve that problem. So you see, that is a problem. That problem needs research-based solution. And he's currently working on that thing today. So that is how one of the ways in which you can identify a research problem and then you pick it up from there. Number five is existing gaps in knowledge. I mean, this number five is very, very similar to number two, where I talked about reading literature. So you find gaps in knowledge in literature. By literature, I mean the papers, journal papers, books that you read. That is what I mean by literature, just in a simple way. So these are areas where very little or no research has been done, right? You can pick these gaps and then you continue from there, right? So signs, I said signs of a good uh, signs of a good research problem. A good research must have all of these, right? It must exist. It has to be something real. It's not supposed to be something that you just imagine. It has to matter. Does solving that particular problem that you identify, will it benefit someone or something? It has to be something unresolved. You know, it has to be something that has not been fully answered before. It has to be something researchable, something that can be studied with the available tools. Let's say, for instance, you want to solve a problem and then you don't have the tools available. How can you solve the problem? So it has to be something that is researchable. It has to be specific. It has to be focused enough to actually investigate, right? So I said there are three levels of a problem. Level one is the broad topic. Let's say I am interested in energy research. If I just come up and I say something like energy and fuel, that is too broad. Yeah, I'm interested in energy research, quite all right. But then if I just say energy and fuel, it's something that is too broad. The topic is too broad. Level two is the narrow area. Let's say, for instance, I say biofuel production. At least this biofuel production compared to just energy and fuel, biofuel production is a little bit narrowed, but then it's still too broad. You can't just start from there. Then level three is the specific problem. I said, let's say, for instance, if I say existing biofuel catalyst deactivate too quickly at high temperatures, reducing production efficiency, this is a problem. So I am trying to look at why is it that catalyst or biofuel catalyst deactivate too quickly when the temperature is high. You see, this is something that I can investigate into. This is something that I can check why this catalyst investigate, or I mean, why catalyst deactivate when the temperature is high. So that is a problem, right? And you can see that this problem is more specific compared to just energy and fuel, compared to just biofuel production. So the next core principle of research fundamental is review of literature, what is called a literature review, right? Literature review is the critical analysis and synthesis of existing literature on a specific topic or research. By literature here, I mean books, journal articles that are related to your topic. In other words, I can say a literature review is the systematic, explicit, method of identifying, of evaluating, and then of synthesizing the already existing body of knowledge, that have been done by researchers, that have been done by scholars, in your field. And it is very, very important to know that without a literature review, number one, you will not be able to fully understand your topic, right? If you don't do literature review, you will not be able to understand that topic that you want to work on. Number two, is that you will not be able to know what has been fully researched and what is left to be explored, right? And then the third one is that I would say you will not be able to know the methods that are appropriate for you to investigate that problem or investigate that topic. And most importantly, you will face the danger of what I call reinventing the wheel. And research is not meant to reinvent the wheel. By reinventing the wheel, I mean by duplicating what others have already done, right? You will face that danger. So literature review will help you to avoid all of these things. You will not just pick what somebody have already done. By going through literature, you'll be able to understand that, okay, so and so thing have been done before, and this is where the gap is. So I gave an instance there where I said the works of literature review could be pictured by an analogy that was made by famous Isaac Newton, where he said, if I ascend further, it is by standing on the shoulders of giants. During research, what researchers normally do is that they climb on the mountain of accumulated knowledge, right? So, literature review is something that is broad. I am just talking about it briefly here as one of the core principles of research fundamentals that anybody who wants to embark on research must know. But there's going to be a separate webinar that is dedicated to literature review or review of literature, because it is more than what I'm just talking about here in one of the upcoming classes that will come up by our senior colleague in the house. So the other core principle is what I call research design and methodology. What is research design? Research design here is I said is your master plan. It is the overall strategy that tells you how you will conduct your research from start to finish. Why methodology is the specific steps. They are the tools that you use to actually collect and analyze your data. When you talk about method, what method are you using? Okay, you have identified a problem, right? What method do you want to use? That's why initially when I started, I said research, is a step, it's a systematic way. That is a step by step, a structured process of doing this thing. This thing is not just done anyhow. So there must be a process of doing it. What is the method? What are the tools that you are going to use? That is what you know um, methodology, or what is called method in research, is the tools that you're going to use. So I just gave a flowchart here, from research problem to research question to your research design, which is the overall plan, to data collection, to data analysis, and then to your findings and and conclusions, right? Findings and conclusions. So there are three core research designs. The there are three core research designs I said. Number one is experimental design. Number two is non-experimental design. Number three is semi-experimental design. And then the main research methods that we have survey methods, we have experimental methods, we have case study, right? I believe all of us on this call, you may have maybe filled something like a Google form before, or somebody's carrying out the research and the person have designed something, that this thing called questionnaire, and the person would be like, please, can you help me fill this questionnaire The person is trying to collect some kind of data. That is the method, that is the methodology section, the method that that person wants to use for that, for carrying out that research, for getting the data. So that is survey method. If you're talking about survey, that is that person is using a survey method to get his or her data. Experimental, because someone can carry out an experiment in the lab in order to arrive at or to get the answer to whatsoever he is trying to solve. Then case study, it could be a detailed investigation into a particular case. It could be somebody, it could be an organization or a company. But I want you to note that research design here is your plan, while methodology is your action. So together they answer one critical question that every researcher must be able to clearly state before collecting a single piece of data. Are we together, please?
Yes, sir.
Okay, that's good. Okay, that's good. Um, the other core principle, or another core principle here in research fundamental, is data collection and analysis. Data collection and analysis. So, what is data? Data is simply any piece of information collected during research that helps you answer um, your research question, right? I said data can be a number, it can be word, can be observation, an image, a measurement, anything that serves as evidence for your findings can serve as data, or is referred to as data. So we have two major types of data. We have what is called primary data. This is the data that is collected directly by the researcher. Let's say if you are the one carrying out that research, when you go out to the field to collect data, that data is called primary data because you are collecting the data, by yourself, right? It is more of like fresh. It is like original to your study, right? And this kind of data takes, sometimes it takes time, and then and effort as well. I said example is running a lab experiment, conducting interviews, administering a questionnaire. These are ways of collecting primary data. The second one is secondary data, right? Secondary data is data that already exists. This kind of data is collected by someone else. It is more faster and cheaper. Example is published journal articles, government reports, consensus data, and then existing database is secondary data, right? So the main data collection tools, number one, questionnaire slash survey. I was talking about survey shortly. I said a survey here, these are just set of written questions that you distribute to people to get data from them. You can sometimes it is online as the world is advancing. People mostly do it online now, but some people or supervisors still insist that students should get it printed and stuff like that. So that is what questionnaire or survey is. It is a method of collecting, or is a tool of collecting data. Number two is interview. This is a direct conversation between a researcher and a participant, right? Number three is observation, where the researcher watches and records events as they naturally happen, right? It is good for laboratory procedures, classroom behavior, and industrial processes. Number four is experimental or experiment slash laboratory instrument. It is a kind of controlled, test using scientific equipment, and it is best for scientific and engineering research. Number five is document review, where you analyze existing materials, reports, policies, publications, right, in order to get your data. So these are the main tools for data collection: questionnaire, interview, observation, experiment in the lab, and then document um, review, right? So the next step we have here is data analysis. What is data analysis? Data analysis is, simply the process of organizing, inspecting, and interpreting, collected data to identify patterns and draw conclusions. All right, and draw conclusions. So this little flow chart you see here, where uh, you see your data, and then from data you have numbers, you have words. When I was talking about qualitative and quantitative um, type of research, which was research by approach, I said that quantitative deals with numerical values, which are numbers, and then qualitative um, deals with you know words. Then from quantitative, like I said, statistical. If you want to analyze it, that is data analysis, it goes down to where you end up having graphs, you end up having um, charts like bar chart, pie charts, and histograms, and all of that. But then for qualitative analysis, they are just themes that leads down to patterns and meanings. So under you know quantitative analysis, you see things like stuff like descriptive statistics, where you're seeing maybe mean, you're seeing stuff like mode, you're seeing stuff like median, and 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 all of that leads down to visual presentations of, like I said, bar charts, line graphs, pie charts, scatter plots, histograms, and and all those statistical analysis that are there. you know so the next one is mixed methods analysis. So mixed method analysis combines the quantitative and qualitative analysis to provide a more complete understanding of a research problem, right? Note that data collection without analysis is just information. If you gather all of this data, and then at the end of everything, your data is not analyzed, um, all you've done is nothing. You just gathered information, because it is this analysis that we you know interpret this data, so that when you present this data, or when this work is published, people will really understand what you did, right? So the goal of research is to turn raw information into knowledge. That means something. Yes, that means something. So the next core principle of research fundamental, which is very, very important, is ethics in research, or what I call research ethics. So what are research ethics? Research ethics are simply the moral principles and standards that guide how research is conducted. They ensure that the process is honest, the process is respectful, the process is responsible to participants, and to knowledge, and to the society um, at large, right? So why does ethics in research matter? You know, history has shown us that what happens when research ethics are ignored, you know, is that it leads to this kind of thing happens, or when research ethics are ignored, it leads to problems, not just to the researcher, but then to the entire society. I was reading something that happened sometimes back. A real example of somebody, um, one of these white people, I think in the UK or something, that This man falsified data. He posted, fake data about vaccines, you know, on, is it autism, something autism? I'm forgetting about the whole thing. Some autism, something like that. So the paper was, retracted, and his medical license, because this person is a medical practitioner, and his medical license was revoked, and then the first claim that he did, or what he falsified from that particular data, you know, caused a global public health crisis, that persists till today. So that is why research ethics is very, very important, that every researcher um, know these things and then keep to it. So I listed some kind of major ethical issues every researcher must know. There are many of them, but then the ones that I feel they are very, very important and are common, especially to beginners, people who are interested in research and are getting to know about research. The number one, very, very common one, is plagiarism. Plagiarism here is simply, when you use somebody's work without crediting or giving credit to that person, right? I said it's presenting someone's else work, ideas, or words as your own without giving credit, without acknowledging. you know it is one of the most serious violations in academic and scientific research, right? In short, in other countries, you can lose your job. You can lose your job because of plagiarism alone, as simple as it looks, right? You can lose your job because of that. So there are different forms of plagiarism, and they include: number one, copying text word for word without citation, right? Number two, is paraphrasing someone's idea without acknowledgement. Or the same thing, when you paraphrase somebody's, by paraphrasing I mean, you pick someone's word, what someone wrote, or a research that someone did, the person founded something, and then you either, let's say for instance, you are doing literature review, and then you pick that particular finding or discovery, and then you write it in your own word, you paraphrase it in your own word, then you don't acknowledge the person, right? It didn't, you didn't do that thing, it didn't come from you. So you need to acknowledge, you need to predict that person. So it's a very, very serious offense, right? Number three is submitting someone else's work as your own. Then there is something called self-plagiarism, right? In academic writing, there's something called self-plagiarism. It's called, you can't use your own work as your own, just like that. Right. So I said self-plagiarism, reusing your own previous published work without disclosure. So it is an offense in academic writing. So note that every idea that is not yours must be traced back to its own original source. Always, always, in academic writing, always. Right. Number two, major ethical issue that every researcher must know is fabrication and falsification of data. Fabrication here, making up data that does not exist. Falsification, manipulating real data to change the outcome. You probably, let's say your data is not giving you the outcome or the desired result, you now change it. That is a very serious offense in academic writing, and it is not um you know accepted at all, right? It's not accepted at all in academic writing. So I said, let me give a real world example here. Yeah, I think this is what I was trying to say. The Andrew Wakefield case, a researcher falsified data linking vaccines to autism. The paper was retracted, his medical license was revoked, and then the first claim caused global public health, crisis that persists till today. That persists till today. So you see what not keeping to research ethics can cause, right? So final thoughts. As I said, ethics is the foundation of trust between science and society. So it's something that, if you're willing and interested to be a researcher, you should have it in mind that you must know these ethics thoroughly to avoid landing yourself into problems. So key takeaway here, you know, research is systematic and evidence based. you know, by systematic, like I said before, step by step process. It is not just done anyhow. It follows a structured process. Every research begins with a problem. When you identify a problem, that is what drives your research. Literature review builds research direction. If you don't carry out or do literature review, you will not be able to fully understand your topic. Like I said previously, data must be collected and analyzed, rest, responsible, and then ethical conduct is essential in every study. Ethical conduct is essential in every study of the process of doing research. So um, this is all that I worked on on the fundamentals of you know research or research fundamentals, right? So I think we have come to the conclusion of this class. I don't know if anyone have a question, right? Otherwise, I am saying thank you.
Please, I have a question.
Okay.
And you talked about self plagiarism, and then
Yeah.
you said something like not is it using your work that you have published without disclosure. Please, can you explain better with an example? It's not
Okay.
clear.
Okay. So when I if I say what I meant by self plagiarism is that let's say for instance you have published a work before, right? And in journals, some journals don't normally give or how do I put this in now? Some journals don't normally allow um let's say you publish a work in a particular journal, and then you come back to um pick or use, let's say, the methodology or the method you use in that particular work in another work, in another, let's say, a research work that you're trying to do, right? You have already published the work before. It is something that you did, but then maybe that journal has a rule that you can't come and pick this method again and use because you don't have um you have not been given that permission by that particular journal, right, to do that. So when you do that, it is called self-plagiarism, right? Let's say you are trying to it is something that you did before by yourself, right? But then you are now coming to pick it again and use. If you try that, probably maybe you may not be caught. But then if it is published in another journal and it is discovered, right, then that may be a problem. So that is um that is what I mean by self plagiarism. I don't know if you have I have tried it, made justice to your question.
Yes, it's clear, sir. Thank you.
Welcome.
I think Bingul wants to talk, right? Who is Bingul? I'm seeing someone raising up his hand or her hand.
Please, I want to ask a question.
Okay, can go ahead.
So you spoke about picking your work without being granted permission or stuff like that. So does that mean it's like picking it and citing it in your work, like citation?
Yeah, exactly.
Okay, thank you.
Yeah. Any other question?
Okay. All right. Thank you so much, sir, for what you said, the class entirely. And so I think I have a question when it comes to the methodology when carrying out a research.
Okay, okay.
Yes. So, for example, I am meant to do a research that has to do with data collection, has to do a number, a population, a sample population of a particular number, and maybe I don't know the actual number of the people, and I'm asked to write a methodology, propose a methodology for how I'm going to arrive there. What am I going to do? What am I going to do for me to be able to come up with a methodology that will fit in that kind of research?
Lisa, can you come? I think I didn't really get that.
Okay. Okay. What I mean is, for example, to do a study, right? And
Yeah,
then to collect samples. So
mm,
maybe I'm to do a study in something that has to do maybe the reaction of students, University of Georgia students, safety departments. You get maybe in terms of research, their reaction or their response to research. And maybe the school does not have a proper data of the number of students we have in SLC departments. And I'm asked to estimate a sample population. What do you think I'm going to do about that, sir?
um, honestly, I don't think I really understand your question properly, or maybe I will go back, try to um get the answer properly. So
Okay, basically what I'm asking is, for example, I'm asked to collect a data, right,
yeah, yes,
of
yes.
of students, maybe students' response in the University of Jos, right, SLT to be precise,
Okay,
and I'm to write a sample, population sample, or the sample size of the population. That's the right word. The sample
mm,
size of the population. Now, if SLT does not have a data set of the number of students, total number of students they have, right? The
yeah.
question is, how am I going to how am I going to write that the formula? Sorry, thank you. How am I going to write the formula for carrying out the sample size? Is there anything that I can use to do that?
Yes. I think you can use what is called you know, do I say sampling method to, or few students or few people who can represent the whole, or who can represent the whole department, and then you can use that to get you know, I don't really know how to put the question, but
Okay,
Mm,
all right.
that's exactly what I want to do because we have like different types of sampling. We have stratified, random sampling. So you pick the one which is efficient for your representation.
All right, that's
or,
true.
sir, do you do you have a better way of explaining the question, or something?
No, at least she tried. She tried. Even you tried. Basically, I think it's about sampling some. Thank you. I think I get the concept, sir.
Oh, okay, sir. Okay, sir.
Awesome.
So, do we have any other question from anyone else?
All right, Dr. Ben, a very good well done to you. You've done well, and we really appreciate your efforts put into making research to make this presentation. You would recall some other time, a couple of weeks past, we had opportunity to meet with the HOD of a certain department, well respected, um, faculty, and he made mention of ethics. He did not ask how intelligent are you guys, how well are you guys able with laboratory practices and all. He didn't ask all of that. he just called his focus on hope we will not be, too forward. And he was trying to address the fact of ethics within the lab, right? And as science students, we our lives will majorly close to 60 to 70% end up in the lab, right? Because you cannot make experiments, you cannot, execute skill research without the lab being part of it. And you also recall some time past our first encounter with Prof. The question he asked was, "Do we have bench work experience?" And the answer then was no, right? So, which means our lives are glued to the lab. And on ethics, can you like still point on that and point out why important ethics is?
Okay.
Can you just
Why
tell us why?
important? Okay, why important? Um, that is your question is why important, you know, ethics is, right? Yeah, can you hear me, Hendrix?
Oh yeah, the network seems very bad, so it's a bit um laggy.
But
But yeah, it's
can you hear me?
Yeah, I think what he's asking is that's what he's asking, how why important is the matter of ethics in regards to laboratory function. And that's his question.
Okay. What I would say is, ethics are very, very important because um, even in the case of the lab, I think ethics we guide how things should be done rightly in the lab, like very, very correct in the lab. If you're someone who wants to follow ethics, right? I believe if you, let's say for instance, you've done the research and then you didn't really get the positive result, or you didn't get the result that you're expecting, you are um, to submit, or you are to, you are to write down that data like that, right? You're not supposed to change anything. You're not supposed to fabricate anything, right? So, like I was saying before, right? Um, like if you look at the history of let's say in terms of research, for instance, now let's say history has shown how that research ethics that were ignored before have caused a lot of problems, right? Let's say for instance something like experiment conducted on humans without their consents, or data being falsified, like I said, or fabricated to support false conclusions, right? These are all done when ethics are ignored. So I believe ethics are very, very important, especially in the lab, like you said, because there is no science without the lab. I remember sometimes ago, Professor Dashak of chemistry department said something like that, that there's no science without the lab. So in the lab, it is even most important that we keep to ethics. We keep to ethics because it will not just lead to problem in the society. Even right as you are in the lab, it can lead to an accident. Maybe you disobey a rule. You say don't do this, or don't add more than this so and so proportion of a chemical, and then you don't keep to that, and then probably leads to something, maybe an explosion that maybe poured on your body, on your face or something. That's that's as a result of not keeping to the ethics. So I believe um, ethics are very, very important in the lab. And then when you keep to, or when we all keep to ethics as lab technologists or as scientists, that we help. I don't know if I've done or say something little else.
Okay, yeah, I think what you said is very absolute, and I think I've I had an experience in regards to the matter of ethics. Yeah, I think one of our seniors, I think 2 years ago, did a work. and the result she had happens to be negative.
Okay.
Now, I love what she did. She didn't fabricate the results, she presented the results. So I saw asked her, why is your result negative? She said, Ma, I followed every procedure and I arrived here. Guess what happened? She got an A.
Wow.
Guess. Yeah, she got an A. What they're expecting to have in the result was supposed to be a positive result. She had a negative result. You get, and she followed every procedure. The challenge with let me use the word Nigerian researchers. I know it's not just a Nigerian thing, it's a global issue, right? But mostly the rate is high in Nigeria, Africa. Now, the challenge we've had is when we begin a research, we already have what the research should look like. If the research does not look like that, we will not agree with it. You get right. So that thing already places us in a position where we have to breach ethics. You get, and that's why this kind of webinar is very important for us to know as researchers, either scientific researchers or researchers either in the law firm, those guys in the library firm, those guys in the education, in the arts. Because there are times you can propose an hypothesis and you are set out to go and do a research. Literature said this is what is there, this is what is there. But when you get out there to do your research, discover that it's not like that. Now, so, and it's not just even just the laboratory this thing, any field entirely that has to do with research. It's very good we maintain the ethics. I think it should be in Uganda. Yeah, either in Uganda or Rwanda, one of those countries. A professor, I don't know if it is you that said it or someone else. A professor came up with a research proposal, stuff like that, and then when he published it, someone else went to go and do the research. He discovered that the man falsified a lot of things, and there were error in what he did. The guy put it out. That guy's professorship was affected. You get, so that's why I keep saying that we in Africa we've got to have that mindset that research can come up with anything. Most of the greatest discovery we've had today, they came up with an hypothesis. While they were doing the hypothesis, he came up with something. Last year in Shade School, we're working on something called proticocine. Proticocine is used to treat breast cancer. They are still working on it. Now, they discovered proticocine in the lab while they were trying to do something else. You get, but if they are insisted that this is what it should be, then maybe they won't arrive at the point of proticocine. So that's my take in regards to ethics in research. Thank you very much.
Well, thank you so much, sir, for that wonderful addition. Yes. Mr. Hendricks, I don't know if that may have or you are satisfied with that wonderful.
Yeah, yeah. Thank you very much. At time you were seeking confirmation on my clarity. The network was very terrible, but yeah, with contributions from you two, I've been able to, you know, expand my idea more. So thank you very much for taking time to answer that. I don't know. Do we still have any more questions, contributions?
I think there are no more questions here in the house.
Okay, so I think let me just say a few things, and I think where the time is fast spent, right? Um, as of course a contribution now. I really appreciate the fact that um, Dr. Ben and Dr. Hendricks and everybody here is a great person, is a professor. I recommend and I celebrate you guys here. I love the fact that you guys are taking time to come up to this kind of event, to come up to kind of meeting and be exposed to such information. Every great researcher had a pathway. Every researcher had somewhere they began from, and then it's a continuous process. It's not a one-day thing. I'll keep saying that if you want to become great, if you had that plans to become great, you have to start somewhere. You make mistakes. You have to learn to take risks. If you make mistakes, but every day with the mistakes, each day you keep learning. So thank you so much for the section. Thank you so much for the class. Thank you so much for this information. And I love your slide. Yeah, I love your slide. It's very,
Bless her.
yeah, I love your slide. The slide is very simple, very direct, no complications. So, and yeah, keep it up. And I love the way you presented. I love the calmness, the articulation, the confidence. I think with this, you are good to go for an international stage. You are good to present on a global stage, and we'll get there very soon as a team.
Yeah,
Should
thank you,
get,
sir.
yeah,
Thank
get
you.
there very soon. So, and everyone here, I think I don't know this person, Gunkol. I don't know Nende. I think I know Nanim, and I'm sure there's someone else too. One of the advantages of stuff like this is building your confidence. Once you can talk to two people, three people online, before you know, we begin to meet physical. Before you know, we're going to push out there, and then you are good. Sorry, let me bring this up here, and then before I leave. This morning, someone was supposed to do. These guys are supposed to do a proposal next week. And then the guy was agitating, the guy was fear, he was afraid. I was now wondering, sir, is department proposal you want to do? Why do you want to feel why do you why are you so disturbed this way? The guy said the slide is too much. I said, sir, I can present your 23 slide into 3 minutes. You get right? Yeah, into 3 minutes, I can do that. You have enough time to do that. It's about being able to articulate what you've learned. It's about knowing what you are to do, and then the delivery. That's it. That's it. I think I've had a lot of I've had presentations where people don't ever ask me questions because I've delivered it. You know it. You understood it. So what else again? So I love the way you took the whole thing bit by bit, step by step, and that's what presentation is all about. So, and I look forward that this lady, Nendin and Co. I love the way you guys, the energy, the way you guys put out questions. I love that, and I look forward to one day. Our moderator, Mr. Hendrik, I look forward to hearing these ladies present. So I don't know how I'm going to work on that, but yeah, yeah, I'm looking
Well,
forward.
we're
We're
gonna
going
work
to
to
work
find
to
a
find a
fit for
fit for
them.
them. Good, good. I look forward. Everybody here should be involved. As long as everybody is consistent, everybody here should be involved. So that's it. Thank you very much, guys. On my end.
Yes, thank you so much, sir. So this is I research, and then we will be having a webinar. Our webinar holds every Friday, and I mean I said every Friday. I think by next week, Dr. Hendricks will be presenting again on digital literacy. You know, he's a guru in that area, and then that will be really wonderful. I beg all of you who are here to also should not miss out, right? As you all, I mean, here you guys should also try to come out again and invite your friends, invite your classmates to, you know, to also join. Yeah. Um. Dr. Hendricks, I think that's all right. We try and leave.
Okay, yes. Yeah. That's all for the call. Thank you very much, Ben, and thank you everyone who has made contributions. We turn up next week Friday again for another one on digital literacy as concerned regards research. Thank you very much. If amidst nothing else, we would end the call.
All right. Thank you very much. Bye, guys.